Hello and welcome back to JD Science Prep. Today we're going to be discussing mole conversion. So I talked about the mole conversion roadmap on a separate video. We're going to be using that today. So if you haven't watched that video yet, go ahead and take a look at that. Let's get started though. So using the amount of moles of a substance, you can solve for the mass of that substance, the number of particles in that substance, or the volume of that substance if it is a gas. Okay, so keep that in mind as we go through some examples here. So we're going to be using that roadmap that we did discuss there in a previous video. So again, make sure you are familiar with that before we get started. So let's move on to our first example here. It says, what mass of calcium chloride is there if you have 4.2 moles of that CaCl2? So first off, in a previous video, we also discussed solving for the molar mass of a substance. So first, if we are dealing with the mass of a substance, the first thing we should think of is figuring out the molar mass of that substance. Okay. So what makes up CaCl2? We are going to have one calcium atom, okay? And as you probably know, we are going to have two chlorine atoms, okay? So let's go ahead and head on over to our periodic table and let's figure out the molar masses of both of those substances. So first, let's look for calcium. So calcium, let's zoom in a little bit. You'll see that the atomic mass and also the molar mass of calcium is 40.08 grams per mole. So that's what we're going to write beside our calcium. So 40.08 grams per mole. And let's head on over to chlorine and see what the molar mass of Cl is. And we zoomed in on it. So the molar mass of chlorine is 35.45 grams per mole. Let's go ahead and write that down next to our Cl. So 35.45 grams per mole. And what we can do now is we can add up our total molar mass for CaCl2. So 1 multiplied by 40.08, you can probably do that in your brain. So 40.08 grams per mole. And we have two chlorine atoms, right, that make up CaCl2 right here. So we have to multiply 35.45 by 2. So if we do that, you should get 70.90. So 70.90 grams per mole. And what we can do with those is we can add them up to figure out the molar mass of our CaCl2 compound. Okay, so if you do add them up, you should get a molar mass of 110.98 grams per mole. So what that means, for every 1 mole of CaCl2, there is 110.98 grams of it. Okay, so we have not solved our question yet. We just figured out the molar mass of CaCl2. So we have another step to go here. Okay, so we have to figure out the mass. We have to figure out the mass of calcium chloride if there are 4.2 moles of it. Okay, so now what we're going to do, I'm just going to make myself a little bit more space here. So we know that our molar mass is 110.98 grams per mole, and I'm just going to get rid of our work here. Then we can focus on figuring out the mass of CaCl2. Okay. All right, so let's start with what we know. Our question gave us 4.2 moles of CaCl2. We're going to write out a time sign line, if you can remember that from our one-step conversion video. Okay. And what we want to figure out is the mass. So the molar mass, what we figured out, is going to go on top because that is what we want. So 110.98 grams of CaCl2 for every 1 mole of CaCl2. Okay? And when you type that into your calculator, you will get the mass of CaCl2 of 4.2 moles of it. So type in 4.2 multiplied by 110.98, and you should get 466, and we have to reduce to sig figs here. So you should get 470 grams of CaCl2. So that is our final answer for example number 1. Right? Let's go on to number 2. This one will be a little bit shorter. So it asks, what volume of helium gas do you have if you have 1.3 moles of helium in a gas cylinder? So before we write down our how we're going to do this, there is one thing we need to know, and that is 1 mole of gas is equal to 22.4 liters at STP, so standard temperature and pressure. So I did discuss this number, 22.4 liters, in a previous video, but that is the conversion factor that we're going to use to figure out the volume of helium gas in this cylinder. Okay. So if we know that 1 mole of gas is equal to 22.4 liters at STP, we're going to use that to flip our 1.3 moles of helium gas to volume. So let's write down what we have. We have 1.3 moles of helium. We're going to do a time sign line. And I'm just going to refer to our moles roadmap here really quickly to figure out where we are and where we're going. So we started at moles. Okay, I'm just going to grab a different color here. We started at moles, and the question is asking us to go from moles to volume. Okay, so if we're going from moles to volume, we need to multiply. We need to multiply by 22.4 liters per mole. Okay, so let's do that right now. Let's head back to our question here. We'll zoom in. So we have 1.3 moles of helium gas, and we're going to multiply by our magic number. So 22.4 liters, and that is over. We are getting rid of moles of helium. Okay. So remember, if our remember what we want will always be on top of our time sign line here. Okay, so because we want volume, liters is going to be on top. We are getting rid of our moles of helium. So if you multiply 1.3 by 22.4, what you should get is 29.12 liters, but we have 2 significant figures in our question, so we're only going to keep 2. So we will go with 29 liters of helium gas. Okay, and that's going to be our final answer for that question right there, 29 liters of helium gas. We just have 1 more example here. This is going to be a 2-step process though. So it says if you have 107 grams of carbon dioxide, how many molecules of CO2 do you have? Okay. So again, because we're working with mass, we see our grams here, right? Because we're working with mass, we need to figure out the molar mass of carbon dioxide. Okay. So CO2, remember CO2 is going to be 1 carbon, 2 oxygen. Let's figure out the molar masses of both carbon and oxygen. Let's head on over to our periodic table here. So we have carbon right here, and the molar mass of that will be 12.01. We have oxygen right beside it. The molar mass of oxygen is 16.00. We're just going to keep 2 decimal places here. And let's write that down in our example here. So we have carbon. We only have 1 of them in CO2. We're going to multiply that by our 12.01 from our periodic table. And what you should get there is 24.02. So 24 point, oh sorry, it's just multiplied by 1. So that's an easy calculation. We'll go 12.01. There we go. That's a little bit better. And oxygen, our molar mass of oxygen is 16.00 grams per mole, and we'll multiply that by 2 because of this subscript right there. There's 2 oxygen in CO2, and we'll get a mass of 32 grams per mole. And remember, we need to add those up to figure out the entire molar mass of CO2. And what we will get is 44.01 grams per mole for CO2. So we have our molar mass figured out. That's a good first step. Now we have to figure out how to get our given mass of 107 grams of carbon dioxide to molecules of CO2. Okay, so I'm going to refer to our roadmap here. Maybe this will simplify it a little bit, because we are going from, I'm just going to make this a little bit neater for us. Get our object eraser out. There we go. We are going to be going from mass. We're going to be going from mass. Whoops, that was my eraser. There we go. We're going to be going from mass and all the way to number of particles. So you will realize here that there is no direct path from mass to particles. There's no direct path. So we're going to have to first make a stop at moles. And from moles, we can get to number of particles. Okay, so this is going to be a 2-step conversion here. So the first step, we have to divide by the molar mass to get to moles. And from there, we're going to have to multiply by Avogadro's number, so 6.022 times 10 to the 23, and that will get us our final answer of number of particles. So let's do that. So first off, we figured out that molar mass there, so we're going to write down exactly what we know. So we know we are given 107 grams of CO2, and first we have to divide by molar mass to get moles. So moles are on top because that's what we want right now. So 1 mole of CO2 is equal to 44.01 grams of CO2. So if we were to stop right here, we would end at moles, but we want number of particles. So we're going to take it one more step here. We're going to multiply this by our Avogadro's number, so 6.022 times 10 to the 23 molecules of CO2. And remember, Avogadro's number is just equal to 1 mole. So for every 1 mole of CO2, there are 6.022 times 10 to the 23 molecules of CO2. Okay? So all you're going to type into your calculator here, you'll go 107 divided by 44.01 multiplied by 6.022 times 10 to the 23, and you'll get your answer. And just notice all of our units will cross out until we're left with what we want here, which is molecules of CO2. So type that into your calculator, and I'm going to write our final answer down here because it is quite a large number. And we will keep 3 significant figures because of 107 grams. So our final answer will be 1.46 times 10 to the 24 molecules of CO2. Okay, so notice it is possible to go from, for instance, mass to number of particles. You will just have to take that extra step, convert to moles first. Okay, that is the end of the video. If it has helped, please like and subscribe.